Hello, I'm Jeff, and this is episode number 10 of the CKong series, where I am reproducing the arcade version of Donkey Kong in C11 and using SDL2. In the last episode, we implemented the how high can you get state and screen. In this episode, we're going to kind of clean up timers. Don't have a reified concept really of timers. I've been doing a couple different things. So in video, I am using SDL get ticks in several places. These are going to be pretty accurate. However, I am calling SDL get ticks in several different places, which means that we're going to get slightly different values for timers. And in the state machine, I'm not using it. I've been relying on frame counts, which if we were on a machine with physical hardware that guaranteed a hard refresh rate, so, a console or a Raspberry Pi or something that would guarantee that we get a true 60 frames a second, and then ideally we would have an interrupt handler for that so that we get those refresh interrupts, we service them right away when they're there. We could pretty much guarantee that counting frames would be legit. But this is software that's running on PC platform, whether it's OS 10, Linux, Windows, doesn't really matter. Modern PCs and modern GPUs don't really expose a very consistent interface for video refresh. And a lot of that has to do with the fact that monitors nowadays don't. Video refresh is to some extent more about latency and timing in the display itself than it is about a CRT refresh rate, where the hardware itself is dictating that, hey, there's a blanking period here. Some does, some doesn't. And if we look at, the game loop here, let's see. Yeah, right here. So I'm doing a software-based frame limiting. If I were to take this out on my machine with the latest version of OS 10, the game runs very fast, hundreds of frames per second. And interestingly enough, if we kind of clean up the timers so that they're not frame-based, then there really isn't a reason why we couldn't just let the frame rate float and execute as quickly as the machine will allow it to run. But this little bit of code here is essentially clamping the game to that approximately 60 frames per second. And the downside to this, of course, is that sometimes other things are happening on the machine and we lose a couple frames per second occasionally. Sometimes the timer is not exactly right, so we go over. And if the frame rate drops significantly, all of our frame-based timers are going to be off. If it goes up significantly, our frame-based timer is going to be off. So we want to move away from frame-based timing because in this particular kind of an implementation environment, it's just not a safe assumption to make. We can't really firmly control. It's not a hard real-time environment like a console or something that's designed specifically to guarantee you a certain refresh rate. So the other thing is the SDL get ticks function can be slow depending on what version of your operating system you have and which operating system you're using. So we want to call this the least number of times possible. And ideally, we would just call it these 2 times in the frame loop to get the start time at the start of the frame and at the end to get the time elapsed for that frame. And we wouldn't call it a lot in between. So what we're going to do is we're going to add a new module. Called timer. And I'm lazy and I don't have different templates for different projects. So I'm just going to copy that. Okay. And then really quickly, let's go to the CMake, this file. It's going to have put these in a sloppy location. So clean that up. I actually have this the other way. Okay. And we'll make sure CMake updates correctly. SDL, unfortunately, the CMake wrapper around SDL just runs the configure script for auto tools. It's a little slow. Okay, looks good. All right, so let's make sure that builds. Yep. All right, here's what we're going to do. So first, before we even worry about what we're going to implement here, we need to kind of clean some stuff up. So the first thing we're going to do is we're going to go to the actor module, and there's an actor update that we call every frame, and we're going to pass in ticks to this. Then here, we're just going to use what's passed in. Okay, so when we ask for an animation, we also have to pass in the current ticks. Okay, so that's going to break some stuff. So let's tidy that up. So in video update, we also need to pass the ticks, because that's going to have to then spider out to other things. And then STL get ticks. So So that's one location. Okay, so then the update for background, I'm just going to pass ticks in. All right, so then down here, I'm going to pass ticks. And then, you know, what we'll do is we'll also pass it into the foreground call as well. Even though we're not currently using it, we'll be consistent and pass it in. And then I guess let's pass it into the pre and post as well. Okay, now we need to, for our blinker, we need to change the callback so that it can take the ticks. So we pass that through. So let's see where we're instantiating blinkers. So here's a callback. So we pass ticks through, and then we can pass it through to the actor animate. And in the level header update, we need to pass through ticks. So you could say, well, why are you passing it everywhere? You know, why not just have a global variable or something? We could do that. I think it's actually just kind of a better practice to get into, to pass data around. And, you know, in some cases, having a module level static variable or even having a global variable is a reasonable solution. In this case, the pain, I suppose you could say, of having to pass the ticks around is pretty minor. And it's explicit, so we know for a fact that that's what it is. And it's one of those things, oops, wrong one. If you get into the habit of kind of thinking about your design this way, it actually makes your code more thread ready. Now, I hesitate, this is not, you know, just passing things in is not a guarantee, but it goes a long way, right? The less common state that you're sharing between, you know, different parts of your system, the better off you are. Okay. So we updated video BG blink takes in a ticks. We updated the two locations that are using that. We updated the callback for it. Now this wraps around to other spots. Right, so then for the state machine, since we know we're passing the state context everywhere within the state machine, let's put the ticks on that struct. And we're calling state update. So that is, yeah, so perfect. This rolls right back up. Frame start ticks. Oh, no, I don't want to pass it. I want to set it. we could pass it, and then, you know, but here we'll set it on the struct and then pass the pointer in, and then video update we need to pass ticks through. Oops, 5 frame start. Okay, so we capture the time at the start of the frame. We pass that tick counter through everything, through the state updates, the actor updates, the video updates. So everything is operating from the same tick count. So that's going to have, I think, a good consequence as well, in that everything will be synchronized, right? So and the amount of difference, the drift, is going to be relatively small. And I think in the case of a game, and you can make the argument that, okay, well, if I call it right when I need it, I'm getting the most current time, and that's true. But again, we're talking about a very small difference. Where are you at? There it is. Oops. And having everything be synchronized, I think, is actually a more desirable property here. Perfect. Nope. This one. Okay. Perfect. Now, so let's just run that and make sure that everything continues to work properly. So far, so good. Yep, good. And then our frame rate is still pretty constant, and our actor animation's working. The blinking in the background is working. So everything that was calling SDL get ticks in line, we've now removed all those. The SDL get ticks call should all be in game, which they are. This is all in the main frame loop. These are part of SDL itself, so we're going to ignore those. And okay, perfect. So now let's go to our new module, because we're still using the frame counting for some things inside of the state machine. So we want to get away from that. So let's do, let's create a new struct. This is going to be a timer. And we also need a callback. So let's cheat and paste. So this is going to be timer, callback, pass in a pointer to the timer, and we pass in the there we go. Okay. So what should our timer have on it? Well, we need a timer callback. Try to be consistent here. We need the start ticks, duration, and let's put a void pointer on here for user stuff if we want it. Okay, pretty simple, right? So let's go to our module, and we're going to do a static timer t, timers, and let's say we can have, I don't know, let's say we can have 128 timers. So this is 8, that's 16, that's 24. So, you know, 3K for that. And then we need a counter. And we'll have timer init and timer update, and we pass in the ticks. Come on, C11. There we go. Ooh. I don't know why it gets so confused. Okay, so in timer init, we're just going to set the current timer index to 0. Let's put an active flag on there. So then we'll loop and we'll just make sure the active is false. And then here, what we want to do is we want to loop. We don't want to loop over the max because that's going to be kind of wasteful. We can just loop over the S current timer as the upper bound because that's how many we've created. We haven't added the timer start or stop yet. We'll do that. So just as a, and then what we'll do is timer T. And I do this just because I think it makes the code easier to read. Doing a bunch of array indexes just, I don't know, it's messy in my mind. So if the timer is not active, we just go to the next one. Then what we want to say, so there's the start ticks on the timer. We want to, if we want to avoid the add, let's design it this way. So when we create the timer, then do we need the start ticks? No. So yeah. So we just store when this timer expires. So when we create it or we update it, we take the current ticks, we add the duration, and we get the expiry. We still do need to store, though, the duration, right? Okay, but here we don't have to do any addition in the loop. So we can just say if ticks that's passed in is greater than or equal to timer expiry ticks, then we're going to call the callback, and we're going to pass in the timer, and we're going to pass in ticks in case the callback needs that, right, for animations or anything like that. And if the callback returns false, we're going to kill this timer. So what does that mean? That means, so if kill, we're going to set active to false. And that's all we have to do there. Otherwise, the timer is ongoing. So we need to take the expiry ticks, we need to reset it. So we take the current ticks, we add the duration. This is the next time the timer's going to fire. So we only have to do the add when we update. We don't have to do it during the check. Again, not that that's a significant cost, but if you don't have to do it, why do it? Could the callback be null? It could, maybe, yes. So if it's null, oops, perhaps if I can spell, jeez, there we go. Oh, right. Okay, that's our timer loop. And where are we going to call that? Well, we're going to call it right in the game loop. So we're going to call it before the state machine updates. Passing in the same counter. So everything gets the same counter, same ticks for that frame. So we update our timers, we update the state machine, the actors, the video, we calculate the frame rate, and we continue. And then in game init, we need to call timer init, and we don't really need to do anything to shut this down. We're not really using any external resources, so we won't worry about that. And okay, so far so good. And to start a timer, we need to pass in the ticks, and the duration, the callback, and the user data. And if we don't have any, that can just be null. And stop is pretty simple, right? It's just going to change the active flag. But for completeness, we'll include it. So If s current timer is greater than or equal to max timers minus 1, we're done. We can't do any more. We return null. What is it complaining about? Oh, forgot to do address of. Okay, then down here, we're going to add one to s current timers, and we're going to return the timer. So here, timer active is true, callback is callback, user is user, duration is duration, oops. Expiry is ticks plus duration. That's it. That sets up our timer. Pretty easy. And then timer stop, we know all that really has to do. If we pass in null, we return, otherwise timer active is false. And this explains here, right, why even in this range, now, and this is the interesting bit. Okay, so now this is interesting. If we stop timers using this system, then they leak. Because all we're doing is we're incrementing. So actually, timer start has to do a couple things. So first, so we don't leak timers. We're going to make a function called find free timer. So this is still bounded by the number of active timers. Because this, we're looking for, so if s timers I active, so if it's not active, then that's the one. Otherwise, if they're all, so we have from 0 to some upper number, let's say there are 10 active timers, timer 5 is freed, okay? So what this function will do is it will find timer 5 in that block. So what we want to do is, because s current timer is going to be the next available timer up to the max. So let's rewrite this a little bit. Let's say find free timer. Oops, and of course this is, got to put this up here because I don't want to forward declare it. So if timer is null in this case, then we'll use the next one. There we go. So what's going to happen? So if we haven't started any timers, then s current timer is going to be 0. This loop will just fall through. We'll get a null. So there is no free timer And actually, we could rewrite this. Yeah, let's do that. So if a previous timer was freed, we find that. Otherwise, we return the next available timer. So then we don't have to do that. And this can come up here. There we go. Voila. Okay, so we loop through from 0 to the number of timers that we've activated thus far. If one of them is available again, we reuse it. Otherwise, we fall through, and if we are, so actually we can rewrite this so it's a little bit nicer. So if scurrent timer is less than max timers, then we return this post increment. Otherwise, well, yeah, then we just return null. There we go. I like that. Okay. So then in timer start, our logic is very simple. Call find free timer, set it up. If this is null, return null. There you go. All right. 83 lines of code plus comments. Not too bad. All right, so there's our module. So we'll just compile that, make sure that doesn't break anything. It shouldn't, because we are calling the update timer now in our code, but there are no active timers, so that's okay. All right, so now let's go to the state machine and let's look at where we're using these frame counters. So message frames, like in the tile editor, is a good example. So let's just change that to be a pointer to our timer, and we will create a callback for it, and it takes in a timer and it takes in ticks. And remember, if we call return false, that will kill the timer. So if you set a timer, the callback happens, you return false, it's a one shot. If you return true, it repeats. And then of course you can have, logic in here that decides whether or not it's a one shot or not. So here we have, excuse me, so here I think we just want to do if message timer is not null. We don't need to do the subtract anymore. And then here we're going to call timer. So this would be stile editor timer, message timer is equal to timer start. And instead of passing frames in here, we got to pass two things. We got to pass the ticks, and then we got to pass the duration. So ticks, duration, message timer, callback. I'll rename that. And we don't have any user data for this. So all this is going to do is set message timer to null on our editor. We're going to return false. That's going to kill the timer. We don't need to worry about messages anymore. And then the call to show message is just updated. So it's context ticks. Now this is milliseconds. So how many milliseconds we want? We want this to be, I said 120 frames. So 60 frames per second, so that's 2 seconds. So that's 2,000. Yeah, all these are the same. And we could do create a macro here. So that we don't have to, so we can just say seconds 2. There you go. Couple more. Oh yeah. I missed one. Where is it? There it is. Okay, there you go. So there's our first usage of our new timer. So we'll test that real quick. Go to a blank tile map. Let's choose, let's choose a funky tile. Let's fill it with, let's fill a row with this girder. So F1, fill row, boom, and there it goes, disappeared. 2 seconds. Let's try it again. Fill column. Ooh, that was quick. That was quick. Okay, that seemed really fast. Seconds 2. Okay. Let's do another row. Yeah, okay, so it's after we reuse the timer. It's then it's running too fast. One with, of course, it is 2 seconds independent of the frames. So as we're before, I was locking it to the frame update we were counting frames. So give or take, we knew that one frame was approximately 17 milliseconds. Here, although it's still locked, the tick is still locked to the beginning of a frame. Right. So let's do this. So I'm going to set a breakpoint here. So the duration looks correct. Oh, I didn't change the palette. That's all right. Let's try doing this a different way. So just as a test, let's get the current ticks when we create the timer, not what's passed in. I have a feeling I may have to like adjust the 1,000 to 1,000. Okay. 1,000. Yeah. So here's what's going on. We're passing in the ticks from the beginning of the frame, but by the time we get around, because we're using such a short duration, we've expired already. So what do we have to do? So we know ticks plus duration. A frame is about 17 milliseconds. Just to kind of see if I can get a similar consistent behavior. Change the palette. 1,000, 1,000. Okay. Ooh, yeah, that didn't work. Yeah, see, it's okay. Ba, 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 ba. So we're calling update, which could trigger timers. which will trigger timers. And then we're calling state update. So depending on how long this takes, so from here to here, depending on how long that code executes, which again, you know, we're not, unless we do something really crazy, we're not going to be talking about a lot of time. It shouldn't be 2 seconds worth. All right, let's do this. Let's see how much time is elapsing. So we can just kind of eyeball what the difference between the two is. See, they're equal there. They're equal there. Okay, now I'm really confused. It's like we're not even, the code's not even taking enough time for the tick value to be different. So why? Work that time. They're still not different. Okay. So something else must be going on. One thing I do want to do here. So if the callback is null, if we fall in here and the callback is null, we're going to deactivate the timer. I don't think that has anything to do with this situation, but so let's make it the ticks that get passed in have to be above the expiry ticks for that timer. Okay. Let's do one other thing. Let's put a byte on there that has the ID of the timer, and in init, let's just set that to the number. That way, we can do this. And then in state machine in show message, and we call start timer. Can log out the ID, because this is going to reuse timers. Okay. Okay, so we used say what? Well, that would explain it. We keep, so timer 0 ticks, it just keeps expiring. Did I forget something? Oh, Jeff. This should have been a not. So let's fix that. So if the timer returns false, then kill is true. It was never killing it. Yeah. See? Simple things. Simple things. Okay. Change the palette. 1 1000, 2 1000, and the timer expires once. One time. And let's fill a column. 1 1000, 2 1000. Perfect. All right. I was going to say, it should work. Why isn't it working? 1 1000, 2 1000. Yeah. All right. So now we don't need to call that anymore. We don't need to log that. We don't need to log this. That works. All right. That looks good. Looks good. Yep. Okay. So we've got that debugged. Now we have a couple others. Let's go to the boot sequence here. So this is doing a frame-based delay as well. So let's get rid of that and put a timer in here. So the duration on this is going to be pretty short. I'm just going to say every second will update. Okay, this is going to be the first case where we're going to pass something here in the user. Oh yeah, state. Sorry. There we go. So in this case, if we have more pallets to go, we return true. Otherwise, we're going to move on and we return false. This is where the timer stops. Okay, so that simplified that, I think. Made it cleaner. So when we enter the boot state, we set up our state variable. We start a timer every second. We're going to get a callback. We set the, and we don't even really need to do that. We'll just do that in the update. And yeah, so now all the update does is just fill the tile map with whatever tile and palette combination we have in that struct. So we're looping through all the pallets two at a time. So as long, every other pallet we're setting. So we return true, so the timer should repeat until this condition is no longer true. Then we pass the state context through the user variable. So we cast that, we pop off the boot state, we push in the insert coin state because that's where we're going to go next, and we reset the timer pointer to null just so it's not set anymore. Return false. Okay. It's a lot slower because I wasn't actually basing it on a timer, it was just on frames. And so each frame is 17 milliseconds. It's pretty slow. So seconds is not really appropriate here. Let's do, yeah, 60th. It's like 16 milliseconds, 16 point something milliseconds. So let's do, we'll do 17. Make it very fast. There it goes. Okay, that works. Just make sure everything else works correctly. Yep. Okay, so I got rid of that one. And yeah, and see here, yeah, that one I'm not going to worry about for now. Where else am I using it? We did it in the how high, right? Yeah, this one. How high frames? So let's just do a timer. So here, this how high duration, that is timer start. Oops. ticks. So we said 3 frames. Now that's no, yeah, we said 3 seconds in this case. So it's 3 seconds, right? Because 3 times 60, yeah, about 3 seconds. So this is actually going to be a truer, should be a truer time. Interestingly enough, we don't really need a callback here. Well, but we do, because, yeah, we do. Never mind. Okay. So for the how high stage, now we just get a timer. We assign it to that pointer. 3 seconds. We set up the, and actually probably what we should do, not that I think it, again, we're talking like probably not even measurable. The tick wouldn't even go up, but we'll start the timer at the end of the setup, right? Because this is doing some looping and, you know, setting up the tile map. So we start the timer. We pass in the context as user value. In the callback, we set the duration timer for this state to null, right? So essentially we're, you know, making sure that our pointer is, it'll be reset, right? And here I'm just being explicit, right? I don't technically need to do this, but if I don't, then it's going to have a value that's just pointing in some random location in memory. Better to make it null. So we cast out our context and we transition. Return false because this is just a one shot. We don't want it to run more than one time. So that will automatically deactivate it. And then the update and leave handlers don't do anything anymore for those states, for that state, I should say. Yep. Perfect. All right. So I think that has transitioned all the code so far that was using frame counts for timing. So I think that's good. All right, let's review that. So in our CMake list file, I have the timer module. Let's take a look at the timer module. So we have our max timers. So they're going to be 128 concurrent timers. I just created a macro that converts a second value here into milliseconds. I create a type def for our pointer to our timer callback function here. And we pass in a pointer to the timer and the ticks, the current ticks. And then the timer struct, So each timer has an ID that represents its integer position in the timer's array. This is just so we can, if we log things out or look at it in the debugger, we can identify a timer at least by its index. We have a user pointer, a void pointer for, so far it passed the context in the callbacks, but we could pass anything. There's an active flag on the timer. The duration of the timer, this is in milliseconds. The expiry ticks. So when we create a timer or a timer updates, we take the current ticks, we add the duration, that becomes the expiry ticks. That way, we're only doing the adds when a timer expires or when we create it, not in the loop when we're checking it. And then we have the callback. Timer init, that goes through and sets up the ID and sets the actives to false. Timer start, this finds a timer that's available. So that's either a timer that previously had been allocated but is now inactive, or if they're all active, we get the next one up to the 128 slots. Timer stop, this just marks the timer as inactive. And then timer update, this is called in the game loop. We pass in the ticks from the game loop, and then this determines if any timers need to fire. So then looking at the module, we have our static array of timers. So as I was writing this, I thought to mention, and got caught up in writing it, I'm sure people probably ask, like, why would you do this, right? Why not malloc a timer when you need it? Isn't this wasteful? And, you know, the answer on that, of course, obviously it all depends, right? If you're on a memory constrained platform, maybe you wouldn't do this. Then again, you just might have a smaller set of concurrent timers. The advantage to this is essentially like an arena allocator, right? It's just a very primitive sort of arena. I'm pre-allocating this space, and I don't have to worry about allocating and deallocating this memory. I just reuse it over and over and over again. So it's like, I guess a pool is a more appropriate descriptor for it. It's a pool of timers, and I pull out an available timer from that pool. And we don't really need to pay the cost of calling malloc and free, malloc and free, malloc and free. So that's why I do it this way, because it just ends up being so much simpler. If you have the memory available, you know, these kinds of techniques where you can reasonably say, well, I know what the upper bound of this is going to be. This is how big the structure is. That's how much memory it is. Well, if you malloced all of it, in other words, if you ended up mallocing 128 timers, you would probably end up having more memory in play than doing it this way. However, if you never allocate all 128, then you are wasting some memory. At that point then, right, once we get everything running, we can lower the bounds on a lot of these static arrays. If we know for a fact that we only ever use 50, right, we can lower the bounds on this to something like 64. Same thing with a lot of the other arrays. So again, it's faster, less overhead. It's easier to conceptualize and think about. This is here. It's always, the memory is always there. As long as we're within the bounds of what we've allocated, we're fine. Anyway, oh, and also this is the way, like an assembly, like if I were writing this in assembly, this is the way I would think about the problem, right? Pre-allocate a chunk of memory as part of my program, and then just use that, versus having to dynamically allocate memory. Anyhow, so we have our pool timers. We have our current timer. So this is, this should like be upper timer, or I don't know, I'll have to think about a better name, but this is the current upper limit into the timers array. We have a helper function in the module, find free timer, that loops over all the timers up to the max allocated so far. If one of them is open, it's not active, we use that. Otherwise, all of them are active, we need a new one up to the limit of the number of timers we have. And so we allocate that and give it back. Otherwise, we're done. We can't do any more, we return null. Timer init, we reset the current timer index to 0. We loop over all the timers, set the ID, set active to false. Timer start, we pass in the ticks, duration, callback, and the user data. We look for a free timer. If we didn't get one, bad things, get a null. Otherwise, we just set all the fields on that timer. We increment the current timer, which we shouldn't be doing. That's a bug. See? That's being handled up here now. That was what I originally had written. I just forgot to take it out. So that would have created all sorts of interesting side effects. Okay. Right, so that's fixed. Timer stop, that just sets active to false, which we can just directly set active to false. But for completeness, I created a function for it. And then timer update, we loop through the allocated timers. If it's not active, we just go to the next one. This could happen because we create a timer, we create 5 timers, 2 of them disable. So now we have 2 of them that are open, waiting to be reallocated. We just skip over those. Then the ticks that are passed in, which this is passed in from the main game loop, if that's greater than the expiry ticks on the timer needs to fire its callback. If it doesn't have a callback, we disable the timer. So this is a case where, you know, the timer's going to fire, it's just going to shut off, and then we move on to the next one. Otherwise, we invoke the callback, passing in the timer and the ticks. And if it's not true, then we want to kill it, right? So this returns false. If it needs to be disabled, then we take the logical not of that makes this true. So if we want to kill it, the timer active flag is just false. And then otherwise, if we don't want to kill it, it means that the timer is going to continue running. We want to set the expiry ticks to the current ticks plus the duration of that timer. And that's it. That's the timer module. So then in video, I had to change signatures on several things. So on our blinker callback for background tiles, we have to pass through the ticks because we're going to change animations, we're going to do things, we need to know what the timer value is. And then in the video BG blink call, this is what sets up a blinking tile section. We need to pass the timer ticks through. Video update, we pass the ticks through. And then, so in the blinker implementation, we get the ticks, and we already had a variable in there called ticks. It's just now we're passing it in instead of calling SDL get ticks. And then video BG update, which is a module, private module function, static function. We pass in the ticks. We pass that through the blinker callback. Then for the foreground, we pass in ticks. The pre and post commands we pass in. We're not using it right now, but passing it through, it's there. If we need to do timer related things, we have everything we need. Then in video update, we pass the ticks through to all the different subparts of the video module. In player, I had a couple functions that are setting up blinkers and timers. So you have to pass ticks into these, and then we just pass those through now as necessary. Level was kind of the same thing. So we just pass that through, the callback and the update function. Then in the game, our main game loop, now we call timer update. So the way to look at this is the start of a frame. We grab the ticks from SDL, so that's a timestamp since the application ran in milliseconds. And we call timer update, so this is going to loop through all of our active timers, fire callbacks as necessary. We set the ticks on the state. We call state update, so this is passing the ticks into the state engine. Then the actor update, we need ticks on that, and then the video update, same thing. So we capture the start of a frame from a time perspective, and that timestamp is what everything bases its activity on. So everything's synchronized at that point. And then for the game init, we call timer init. There's no explicit shutdown. It's not really necessary. Then for actor, we pass the ticks in for the update, and then for actor animation, this is what sets up an actor's animation. We pass the ticks into that as well, because it's setting up kind of its own specialized timer on the animation. So we take the ticks in here, and then we use that in our animation logic, right? So the actor animation code was already based on the internal SDL timer. It wasn't based on frames. So we just pass the tick value in instead of getting it on the fly. And then actor animation, same thing. We pass it in and we use that to calculate what the first frame of animation's delay should be. And that was it. I changed the order or something, so I just want to make sure that I didn't break anything. I don't think I did. That looks good. Yep. All right. All right, that'll do it for episode 10. I will see everybody in the next episode, and we will continue to work on implementing more states in the game itself and getting more behavior going. So have a good one. Thanks.